The human body is made of more than 20 chemical elements. 96 of its mass is composed of carbon, hydrogen, oxygen, and nitrogen. So there's a word that can help you to remind this. CHON. There is carbon, hydrogen, oxygen, and nitrogen. And well, in contrast, there are other elements found in smaller proportions, such as calcium, phosphorus, which add up to 3%. And well, there are a smaller percentage, like 1%, of like potassium, sulfur, sodium, chloride, magnesium, iodine, iron, and zinc. So all these elements are indispensable for life. So the percentage distribute of elements on Earth is that oxygen, silicon, aluminum, iron, calcium, sodium, potassium, and magnesium. Then, well, in the Earth's atmosphere, is mainly comprised by nitrogen and oxygen. The nitrogen is at 78.08%, and the oxygen is 20.95%. And well, there are other gases and that are in smaller quantities, such as argon and carbon dioxide.
Atom structure. The atom is known as the basic unit of a substance that cannot be chemically decomposed, and the atom is characterized by being impossible to visualize by the human eye, even with some advanced microscopes. And about the internal structure is made up of three subparticles that are the proton, the neutron, and the electron. The proton that has a positive charge, the electron that has a negative charge, and the neutron that has a null or zero charge. About the location of the subatomic particles in the atom, the protons are concentrated in the central part of the atom, known as nucleus, along with the neutrons, while the electrons are found around the nucleus and orbit about it.
In 1950, researchers carried out that showed that atoms have an internal structure made up of three subparticles: protons, electrons, and neutrons. The development of atomic theory opened the door for discovering the first atomic subparticle. In 1997, J.J. Thomson demonstrated that cathode rays travel in a straight line are negatively charged because they are attached to the positive flame, are repelled by electric and magnetic fields, have shadows, and can move small bodies. These negatively charged particles are called electrons. In 1910, the scientist Ernest Rutherford described protons as positive subparticles concentrated within the nucleus. In 1932, James Chadwick, in some of his experiments, bombarded boron atoms and calculated that the particle added to boron had a mass equal to that of the proton. He also detected that it has no charge, so he called this particle neutron. This particle is located in the nucleus of the atom with the protons.
Elements, as we all know, have three particles that conform them. All elements are composed by these three particles. For example, in oxygen there are 8 protons, 8 electrons, and 8 neutrons, and every element is defined by the amount of these particles, except for neutrons. Isotopes are elements that have a different amount of neutrons that they usually have. This may give them some properties, like make them radioactive, or special properties depending on the isotope. A great example of isotopes is deuterium, also known as hydrogen-2, and it is component of the known as heavy water. And this isotope is composed of 1 electron, 1 proton, and 1 neutron. Other common reference isotopes are carbon-14, used as a datation indicator in archaeology, and it is actually radioactive. So, yes, this is common in some isotopes. As we see, isotopes are very useful sometimes, and they can stabilize heavy and radioactive elements such as uranium, or stabilize for a bit longer some really heavy nucleus elements like deuterium or cesium. And who knows what will be the next use for these peculiarities of.
In Rutherford's model, he established that the atom comprises two regions, a crust and a nucleus, where the proton is a nucleus component. 2. He builds a model in which a nucleus forms the atom, considered a small region that is in the center of the atom and has the positive charge, and that around it are the electrons. Describing different trajectories, known as a planetary model. 3. Positive particles were originally named channel rays, which he later called protons, and he mentioned that electrically neutral atoms have the same amount of protons as electrons. 4. The nucleus has almost all the mass on the atom. J.J. Thomson, in his proposed model, the atom comprises negatively charged particles engraved in a positively charged sphere, making it look like a pudding with raisins. 2. The electrically negative particles present in matter were called corpuscles, later called electrons, distributed uniformly in the atom. 3. He established that the atom is neutral so that the positive charge compensates for the negative charge of the electrons. 4. He conceived of the atom as a compact and indivisible particle. Evolution of atom models. Dalton postulated that all elements are made of tiny particles called atoms. The atoms of the same element are identical. They have the same size, mass, and chemical properties, and therefore are different from those of other elements. The atoms of an element are not created or destroyed during the chemical reaction, but only rearranged. The atoms of various elements form compounds. The ratio of the number of atoms between two elements present will always be an integer or a fraction. Dalton's atomic model conceives the atom as a solid sphere.